this is Irene Chapara, and I would like us to discuss a polynomial and how we can find the formula of this polynomial given a graph. So we have now a more complicated graph than usual. So let's first of all know exactly what we want to do. We are going to look at the graph, find the x-intercepts, the y-intercepts, create a table that will help us identify the factors of the polynomial and the multiplicity of each factor, and then we will find the leading coefficient for that polynomial. So we start, and first of all we see that the curve crosses the x-axis at the points -3, -1, 2, and 4. So the x-intercepts are the numbers -3, -1, 2, and 4. Since these are the x-intercepts, these are also the zeros of the polynomial. We write them down in our table: -3, -1, 2, and 4. Now, for each one of those zeros, we find the corresponding linear factor. How? Well, we have to look at what factor has as a solution the corresponding zero. So since -3 is a solution for x plus 3, x plus 3 equals to 0 gives me that x is equal to -3, then this is the corresponding factor for the -3. X plus 1 is the factor for the -1. X minus 2 is the factor for number 2. And x minus 4 is the factor for 0 equals to 4. Now that we have identified the factors, we can also write them down in our polynomial. Definitely this will be part of the polynomial, especially if we factor this polynomial out. But the next step that we want to take is to see what is the multiplicity for each one of those factors. In order to find the multiplicity, and remember that the multiplicity is nothing else than the exponent of the corresponding factor in the format of the polynomial. So this is going to be nothing else than the multiplicity of the corresponding factor that we find in our table. To find the multiplicity, we look at our graph and we identify how the curve crosses the x-axis. So right here we have a table with possible multiplicities, and we need to identify to match basically the case that we have on our curve. So we look right here and we can see that at -3 the curve crosses the x-axis, just crosses it going upwards. So this means that we are in this case where the multiplicity is 1. So this means x plus 3 has multiplicity 1. Now we look at -1 and do the same. At -1 you can see that we have a snake. It is clear that we have a snake, but it's not a plain snake. Basically the line lingers on the x-axis and then it goes down. So we have this case, and I can tell you up front that you can consider the number 5 for this. It is not easy to identify if it's 5, 7, 9, and so on. So usually somebody will let you know in some way what type of number you should consider for this case. So the multiplicity for that is going to be the number 5. Now in the next case we have the number 2, and you can see that we have a plane parabola here, so it bounces back. Since it bounces back, then this means that the multiplicity is 2. We are in this case right here. And in the case of 4, as we can see, the line crosses up, just crosses, so the multiplicity for that is 1. So now that we have these multiplicities, we can enter them in our polynomial. 1, 5, 2, and 1. So basically, I have found all the factors. The only thing that I'm missing is the leading coefficient. The polynomial will look a times x plus 3, exponent is 1, so I can skip it, x plus 1, exponent is 5, x minus 2, exponent is 2, and x minus 4, exponent is 1. I can skip it. Okay, so I have partially my polynomial. The only thing that I'm missing is the leading coefficient. In order to find the leading coefficient, I need a point, and the easier point that I can consider is the y-intercept. The y-intercept is when the polynomial at point 0, and this, as you can see, is equal to -2, I'm sorry. The number is -2. So the y-intercept right here is nothing else than the point 0, -2. So I find the p at 0 that is equal to -2. I see that from my graph. Now, I already have the formula for p of x. The only thing that I'm missing is a. So this means that the p of 0, that is from the one side equal to -2, it is also equal to a times x plus 3, but the x is 0, so it's 0 plus 3 times 0 plus 1 to the 5th times x minus 2, that the x is equal to 0, 0 minus 2 to the 2nd, 0 minus 4. Okay. Now I simplify that and I have -2 is equal to a times 3 times 1 to the 5th, that is 1, times -2 squared, that is 4, times -4. So this means that I have -2 equals to 3 times 4 is 12, 12 times 4 is 48, minus 48. I solve this equation for a, and this means that my final answer is 1/24. So that's the leading coefficient of the polynomial. So I can go back and replace in my polynomial formula the a with 1/24, and this is my final answer. The polynomial p of x is equal to 1/24 times x plus 3 times x plus 1 to the 5th times x minus 2 to the 2nd times x minus 4.